Okay, here we go. We're going to look at how to solve equations graphically now, specifically for us using our Texas Instruments TI-83 or TI-84 calculator. But the idea is we have a lot of really nice methods that we can use to algebraically solve equations. In this class we have a whole section on linear equations. We'll have a whole section coming up next on quadratic equations. We have one section that's just called other types of equations. So we're going to look at lots of methods to symbolically algebraically solve equations. But there are equations that there are no algebraic techniques to solve. Okay? A mathematician named Galois a long time ago proved that you can't solve polynomial equations higher than fourth degree. All polynomials. Some you can, but in general you can't solve explicitly using algebraic techniques any polynomial with a degree of 5 or higher. So we need other ways to do that. So we have numerical methods. Before calculators and computers, they could still do this with a lot of brute force, but these days it's much easier to do this using graphing calculators and software. So I'm going to show you how to do that. There's a couple of ways to do it. We'll look later on in this section about how to use intersections. There's an intersect command on your calculator. But one way to solve an equation is to set everything equal to 0. If it's a one variable equation, we can set it equal to 0 and then try to find the x-intercepts. Okay? So if you have an equation involving x, move everything to one side, put it in the general form, some function of x equals 0, and find the x-intercepts with your calculator. Okay? And different calculators have different ways. Ours has a built-in function called zeros that I'm going to show you. It says you can use zoom and trace, but that's not nearly as accurate. You want to use, if you have a Texas Instruments calculator, to get accurate to the precision, the number of decimal points your calculator has, we have a function that'll do that. And that's what we're going to do next on a couple of examples here. First, we're going to use a TI-83 or 84 to approximate the solutions to 3x to the third minus 4x plus 1 equals 0. So I'm going to pull up my TI Smart View calculator here and go into y equals, clear out whatever I have in there, and here we go. We got 3x to the third minus 4x plus 1. So it looks like mine has the math print turned off, which is fine, but we have 3x to the third minus 4x plus 1. And I'm going to hit zoom 6. May or may not fit in the standard window, but I always start with that. I think it probably will on this one. Yeah, there we go. So we've got 3 x-intercepts. This might be a good place to zoom in. Let's try just regular zoom in first. I might want to use zoom box. Let's do zoom in around the origin here. And I think this is going to look good. Yeah, part of the max there runs off the screen, but I'm looking for the x-intercepts. This looks good. Okay. So the slide said you could just keep zooming to get closer and closer, and you could use trace and you could kind of approximate. You can see, oh, we got an x-intercept around 0.2 something, but I can do much better than that. If I hit second and trace, just like in a section where we found max and mins, go into that menu and choose number 2 to find the zeros, the x-intercepts. And just like finding max and mins, you have to give it a left bound, a right bound, and a guess. So depending on which one we want to find, and you can type numbers in. I think the scale is still counting by ones here. There's one somewhere between -2 and -1 coming from the left to right. So for my left bound, I could either move, if I wanted that one, I could move across the graph until I eventually get to the left. It's going to take a while here. Get to the left, keep going to the left till you go past the x-intercept. And then I could hit enter to set the x-intercept there, or to set the left bound. And then go to the right. Just go to the right until you pass the x-intercept and hit enter. And you set the bounds and the solution's somewhere in between, and I hit enter a third time. And there you go. We've got one at about -1.26 if we round it off. Okay. I'm going to do that same one again by manually entering the left and right bounds. So second, trace, and number 2. So when it asks for the left bound, we're looking for the x-coordinate of the x-intercept there. It needs an x-coordinate that's smaller than that for the left bound. So I can either move along the graph and hit enter when I get to a point that satisfies that, or I can just type in like -2, hit enter, and that'll set a left bound. And then I could do -1 for the right bound. So that'd be another way to do it. You can either click on the graph where you have x-coordinates to the left and right, or you can manually type them in if that's quicker. So we've got an x-intercept at about -1.26. We've got 2 more though. So second, trace, and number 2. And it's going to be quicker if I type them in. I'm going to do, for this one, I'm going to do 0 as a left bound and about a half as a right bound. And so my x-intercept is in there. Hit enter a third time. So we've got one at about 0.26. And there's one more, which might be right at 1, but let's check and see what our calculator says. Second, trace, number 2. This one I'll move on the graph. So enter on the left, enter on the right, and there you go. This one is exactly at x equals 1. And it didn't happen here, but sometimes you'll see that algebraically we can be more accurate than the calculator. The calculator has a numerical routine that might get a little bit of round off error. I wouldn't have been surprised if it didn't tell me it was like 0.99999 something or 1.000 something, but it's exactly 1, and the calculator got that this time. Just one other thing I'll say is you might have noticed my calculator had vertical lines all the way up and down the screen when I clicked and set the bounds. Some of the older calculators don't do that. They just show you the little arrows where you set them, which is all you need. Okay, let's go ahead and do one more here. So use a TI-83 or 84 to approximate the solutions to x squared plus 3x minus 8 equals 0. So a quadratic equation that we could solve with the quadratic formula we'll look at in the next section. But we've got x squared plus 3x minus 8. I'm going to do zoom 6. So we've got 2 solutions. The parabola hits twice there. So second, trace, number 2. And I could count and set the left and right bounds. Probably be quicker, but let me move along the graph. So go to the left, somewhere over there, left bound, right bound. And so about negative 4.70. I usually go about 2 decimal points. And then second, trace, number 2. I'm going to type these. That one's between 1 and 2. So 1 has a left bound, 2 has a right bound, and about 1.70. Okay. So that's how I can use my calculator and the 0 command to solve equations. Just make sure you're looking at a function of x equal to 0 and then find the x-intercepts with the 0 command. Left bound, right bound, guess. You got to trap it in between and you can find it.